The battery has been around for many years. The term battery actually refers to a series of individual cells being linked together. The basic concept of a battery is to force electrons out of the cell and into an electrical circuit to perform work. When describing battery cells, the term primary is used to indicate the cell is not rechargeable. The term secondary refers to a cell that is able to be recharged. The term dry cell refers to a battery containing a moist paste as an electrolyte. Likewise, the term wet cell refers to a battery that has a liquid electrolyte. One of the simplest batteries is a zinc-copper cell. The anode is where electrons flow out of. The cathode is where they collect. The electrolyte and power cable act as bridges, allowing the chemicals in the cell to react. Severing either of these, and the cell will cease to function. The anode in this cell is made of zinc, whereas the cathode is made of copper. Because the copper has greater electron affinity, the freed electrons flow to it rather than the zinc. The plate of zinc is immersed in a solution of zinc nitrate, and the copper plate is in copper nitrate. When the circuit is closed, the reaction begins. The copper is reduced when, after receiving 2 electrons, the copper ions release their nitrates and form solid copper on the plate. On the other side of the cell, zinc on the plate is oxidized as it loses 2 electrons. Because the 2 nitrate solutions are linked with a bridge of potassium nitrate, a nitrate from the copper side is pulled into the bridge, and a nitrate on the zinc side is released. This process will continue until either the circuit is broken, or the chemicals in the cell are depleted. Because the nitrates and the potassium are not reduced or oxidized, they are labeled as spectator ions. Because water is polar, it is excellent at dissolving ionic compounds such as electrolytes. When potassium hydroxide is dissolved in water, the ions are attracted to their opposites. One of the earlier commercial batteries is the zinc chloride cell. This is not the same chemistry as the alkalines that you may use. Zinc chloride batteries are often labeled as heavy duty. They are primarily used as flashlight batteries. They are often cheaper than alkalines, but are not as efficient. Its basic components are a carbon rod, used as a current collector. The rod itself doesn't play any part in the reaction, it is simply to help move the electrons out of the cell. The positive electrode is made of manganese dioxide, which will receive electrons during reduction. There is an electrode separator to keep the zinc and manganese from touching and shorting out the cell. The negative electrode is made of zinc and will be giving up electrons as it is oxidized. A gasket is in place as a safety feature, should gases from the reaction build up pressure inside the cell. A positive terminal is where the connection between the carbon rod and the outside circuit is made. A negative terminal does the same for the zinc cathode. When the reaction begins to take place within the cell, the zinc is oxidized and releases 2 electrons. Those electrons travel through the outside circuit and into the manganese dioxide paste. They combine with water and the manganese to release 2 hydroxide molecules. Part of the electrolyte is made of ammonium chloride. The hydroxide takes a hydrogen from the ammonium and becomes water. The ammonia then combines with the chloride and zinc to become zinc ammonium chloride. The manganese oxide hydroxide will decompose into manganese dioxide and hydrogen, then into dimanganese trioxide and water. The primary electrolyte in this battery is zinc chloride. The chloride acts as a spectator ion. The reason there is a mixture of ammonium chloride and zinc chloride is because ammonia helps the cell be more efficient. This cell is non-rechargeable. Once the reaction takes place in the battery is normally discarded. The basic nickel-cadmium cell has a positive electrode sheet made of nickel, separated by a nylon or polypropylene sheet. A sheet of cadmium acts as the negative electrode, which also has a corresponding separator. All of these sheets are wound into a tight spiral in the middle of the battery. The positive electrode is connected via a small strip of metal to the nickel sheet. The casing is in contact with the cadmium electrode to form a negative terminal. To prevent shorting out of the battery, a separator, or the labeling, is used to keep the casing and positive terminals from touching. A vent is also included to increase safety should gases build up. As the reaction begins, the cadmium and two hydroxide molecules combine to form cadmium hydroxide, which releases two electrons. Those electrons travel out of the cell and into the positive nickel electrode, causing the nickel hydroxides to combine with water. That reaction produces nickel oxyhydroxide and two hydroxide molecules. The two hydroxides travel and react with the cadmium in the first part of the reaction. The whole reaction can be written like this. During the reaction, the potassium hydroxide molecules are spectator ions and just act as a bridge to allow the hydroxides to move around the cell. The whole reaction is reversible, and that's what allows us to recharge batteries. The standard car battery is a lead-acid battery comprised of 6 cells. The other batteries discussed prior to this have been single cells. Each cell has a negative electrode made of lead. The positive electrode is made of lead dioxide. The reservoir inside the battery is filled with sulfuric acid that acts as an electrolyte. The process of getting electric from the battery begins when the sulfuric acid decomposes and a sulfate ion combines with lead to form lead sulfate. This then releases 2 electrons. Those electrons pass outside the battery and enter the cathode. Hydrogen and lead oxide then combine to form lead sulfate and water. The reaction is reversible and allows the recharging of the cells when the electrons are pumped into the anode. There are a few other battery types not discussed, such as lithium and fuel cells, but for the most part they rely on similar principles. Batteries are an interesting and important aspect of our lives, and their chemistry will continue to power our world for many years to come.